Welcome back, everybody. We're welcome, in this case, to the analysis of variance chapter. We are now getting into the analysis of variance, meaning the one-way analysis of variance chapter. So we're going to start talking about what analysis of variance is in just a moment. But first, let's start with a review question. So this is a review question. Let's start with this. McDonald wants to know if people like their Justin Bieber advertisement more than their Beyonce advertisement. So they randomly show half of the YouTube viewers one advertisement, the other half they show the other. Then they measure the preference for which ad. So this is just asking, I've got a Justin Bieber ad, I've got Beyonce ad, which one do people like more? You tell me which test I would use. Half people saw Beyonce, half the people saw Bieber. Okay. The answer to this question is you would use an independent samples t-test because you either saw Justin Bieber or you saw Beyonce. Now, up till now, we've been talking about two groups like that, either Bieber or Beyonce, right? One or the other. But what if I had a separate Jay-Z ad that I wanted to be involved, right? So I had Bieber, Jay-Z, and Beyonce. I had three groups. Well, an independent samples t-test can't do that. A one-way ANOVA can. ANOVA stands for Analysis of Variance. You remember variance? We've talked about variance before lots of times. In fact, what we're going to do is we are going to use the variance between the three different groups. So between Justin Bieber, Beyonce, and Jay-Z, right? Between those three groups. And then we're going to look at the amount of variance that's going on inside of each one of those groups. And we're going to use those two things to figure out whether or not they're significantly different from each other. So let's go ahead and give you some information here. When to use ANOVA? There's two kinds of analysis of variance. The one we're talking about today is a one-way ANOVA. You use that when there's three or more levels of one independent variable. Okay, so overall, we're using analysis of variance. We want to compare two or more groups of continuous data, and I don't know sigma in this particular case, right? Well, in this one, the two or more groups are two or more levels of one independent variable on a dependent variable. That's one-way ANOVA. Factorial or two-way ANOVA is when you have two or more independent variables, and we call those factors. That's going to be the next chapter, and so we'll worry about that a little bit later. So let's go ahead and begin talking about one-way ANOVA. This is where we've got three groups that we want to compare to each other. They're three levels of the same variable. For example, artist would be the variable, three levels. Now this independent variable is going to be categorical. It's going to always be categorical, okay? It's got two or more levels. It can be three, it can be four, it can be five, it can be more than that. So the one analysis of variance is awesome because it can handle more than two groups at a time. All right, when we are calculating one-way analysis of variance, we're going to start with the sum of squares. You remember the sum of squares? We spent so much time at the beginning of the semester talking about the sum of squares. We did it over and over and over again. And it's because we use it for all of what we've been doing, right? Analysis of variance, and variance comes from the sum of squares. So here's what we're going to do. We're going to calculate the total sum of squares. And that's just taking everybody in the sample. We're not splitting anybody out. We're taking everybody in the sample. We're getting their sum of squares for the whole sample, everybody. That's the total. So that's normal, like we've already done it. But then we also need to get what's called between groups and then within groups. Sometimes within groups is called error. So, but the between group sum of squares is going to be the sum of each group's square deviation multiplied by the group's mean. So here's what's going to happen. We're going to split into three groups. Okay, we're going to take the whole sample, we're going to split them into three groups. We're going to be the liking scores for Beyonce, the liking scores for Justin Bieber, and the liking scores for Jay-Z. The three groups. All right? Now, each one of those is going to have a mean, right? And we're going to compare that mean to the grand mean. That sub GM, that means grand mean, and the sub J means group, right? So each of the groups. So we're going to take the mean of the Jay-Z group minus the mean of everybody. We're going to square it, and we're going to times it by the number of people who were in the Jay-Z group. All right? Then we're going to do the same thing for Justin Bieber. We're going to take Justin Bieber's liking mean minus the grand mean, overall mean. We're going to square it, and we're going to we'll multiply it by how many people were in the Justin Bieber group. Then we do the same thing for Beyonce. Beyonce liking mean minus the grand mean, overall mean, squared times the number of people who saw Beyonce. We add each of those up. We're going to get what's called the between groups sum of squares. Within group sum of squares is going to be the sum of each group sum of squares. So I got a sum of squares just for the Jay-Z group. I got a sum of squares just for the Beyonce group. I got a sum of squares just for the Bieber group. I add each of those up. All right? Let's show you an example, and then we'll get into the other steps as we need to. So I'm going to show you some data. Here's some data that I've been using. Let's move this over so that you can see it really well. I'm going to add well, I guess it's not going to matter too much here. Let me just insert some variables so that you can see it more clearly. Okay. So here's what's going to happen. I have 24 participants, right? So you notice how participants 24 participants. I measured what sport they prefer, because here's my hypothesis. My hypothesis is that snowboarders spend more time on the mountain than do skiers or people who prefer neither snowboarding nor skiing. Now that's three groups, right? Snowboard, skiing, and people who prefer neither. Okay, so here's what we're doing then. We want to see if there's a difference between time on the mountain for the snowboard group, time on the mountain for the skiing group, and then time on the mountain for people who neither like skiing nor snowboarding. So let's go get some information first. This is the basic stuff that we've always gotten. Let's get the mean equals the average, the mean of everybody. This is going to be the grand mean. So the mean of everybody is called the grand mean. So the average time on the mountain for everybody in my sample, all 24 people, is 13.058333333 hours. Okay? Next, let's go ahead and get the sum of squares. Now, we can go through the process of getting each one of the deviations, et cetera, et cetera, et cetera. But let's go ahead and I'm just going to use the function here in Excel. And that's DEVSQ, which is the deviation squared, right? And we're going to add them up. We're going to go right here. And that's going to be the sum of squares for everybody, right? So this would be the sum of squares total. 7.978333. Okay, that's the sum of squares for the total. Okay, but when we're talking about analysis of variance, what we're really doing is we're splitting these groups up, and we're comparing their means and their standard deviations to the grand mean, the grand standard deviation, and to each other. Okay, so let's go ahead and put these into three different groups. And I'll move this over right here. This is going to be the snowboard group. This is going to be the skiing group. This is going to be the neither group. All right, here's all my snowboarders. Okay, so this is the number of hours they prefer to spend on the mountain for the snowboarders. This is my skiing group. And this is the neither group. Okay? Okay, now that we've gotten everybody into a separate group, we've got the snowboarders, the skiers, and neither, each in their separate group. Let's go ahead and get the mean and the sum of squares for each one of those. So the mean is going to be the average for all of these people right here. Okay? And then I'm going to do that for the other two groups as well, but I'm going to make sure that we've got the right number of people here. So let's make sure that goes to the right place, 8. And because we have a different n, I'm just making sure that each one of these is in the right spot. And 9. Good. Okay, and then we also need the sum of squares. So the sum of squares for each of these equals the deviation squared of each of these, and it's going to be, whoops, I don't want the mean involved in that one. There we go. All of those. And we're going to do that for each one of the groups. We're getting the mean and the sum of squares for each of these different groups. So, good. And then this should stay the same, but just to make sure, in case we mess something up later on, make sure those are right. Okay, so this is the mean of all the snowboarders and the sum of squares for all the snowboarders. This is the mean for the skiers and the sum of squares for all the skiers. This is the mean for the neither group and the sum of squares for the neither group. All right? Okay, now what we need to do is we need to find the between groups sum of squares. Remember, this is the total sum of squares, right? Just like that's the grand mean, this is the total sum of squares. So now we need to get the between groups sum of squares. Now to do this, let's go ahead and take a look. We're going to take the sum of each group's squared deviation multiplied by the group's mean, right? Not by the group's mean, I'm sorry, this should be the group's n. That's what that should say. Oh my goodness, sorry, that says mean. Typo. So multiplied by the groups, let's go ahead and change it. There we go. Multiplied by the group's n. So what does that mean? All right, well, all that means is we need to get the deviation for each of the groups. So the deviation is the same kind of deviation that we've always done, right? So it's going to be x bar minus what? Minus the grand mean, okay? And we just do that for each one of the different groups, okay? So let's go ahead and do that then for this one. It is the deviation is this minus the grand mean. And so is it over here, the same thing equals this minus the grand mean, which is right there. Okie doke. Got it. Now we square those. Okay. Which is going to be this squared. We're going to do that for each of the groups. Then, instead of just adding these up, we have to multiply them by the number of people in each group. Okay? So this is going to be deviation squared times n. Lowercase n in this case means the number of people in each group. So for example, there are, let's see how many snowboarders we got. 1, 2, 3, 4, 5, 6, 7, 8, 9 snowboarders. So the lowercase n for snowboarders is 9. There are 7 skiers and there's 8 people who are neither. So what we're going to do is we are going to take this deviation squared times n. In this case, n is going to be 9. We're going to do that for each of the different groups. So for this one, it's going to be the deviation squared times 7. And for the neither group, it's going to be the deviation squared times 8. And when we do that, we get those numbers. The between groups sum of squares, it's called the between groups sum of squares, is going to be the sum of those 3 numbers that we just created. It is going to be the deviation squared times n for the snowboarders, for the skiers, and for the neither group. 3.636. The within group sum of squares is easier to find. If you remember, within is the sum of each group's sum of squares. Okay? All that means is, remember we got the sum of squares for each group, right? Here's the sum of squares for snowboarders, here's the sum of squares for skiers, here's the sum of squares for neither. We're going to add those up. Equals the sum of these 3 sums of squares right there. Right? Now, if we did this right, then between group sum of squares and within group sum of squares should add up to the total sum of squares. And let's see if we did it. Let's see. Whoops, I got to equal some. 7.978, 7.978, we did it. They're the same. This and this are the same thing. We just calculated the within groups, the between group sum of squares and the within group sum of squares. And those add up to the total sum of squares, which is the sum of squares of everything, the total sum of squares. All right, back to the slides. So what we just barely did was we calculated step one, the sum of squares. We got the between group sum of squares and the within group sum of squares. Those equal the total sum of squares. Now what we need to do is we need to get what's called the mean squares for the group and for within. Okay, now this looks like a lot of stuff. It's really not that big of a deal. We take what we just got, the sum of squares for the group, and we divide it by the degrees of freedom. And that's all we're doing. We're dividing each of those sum of squares that we just created by the degrees of freedom. In fact, we don't even need to worry about the total anymore. We don't care about the total anymore. We're going to get the mean squares for the group and for within, and that's all we care about. The only thing that you should know is the degrees of freedom for the group. Well, that is the number of groups minus 1. So J in this case is the number of groups. Number of groups minus 1. The degrees of freedom within is all the degrees of freedom of the separate groups, right? Remember how we added up the sum of squares for each of those separate groups? We're just going to add up the degrees of freedom of each of those separate groups. So each of those groups has a degrees of freedom of n minus 1, okay? And then we're just going to add up each of those degrees of freedom. So let's go ahead and do that with the data that we have. So let's get the degrees of freedom for each group, and then we're going to get the degrees of freedom for both. So this is the between degrees of freedom. Okay, how many groups do we have? We have snowboarders, skiers, and neither. 3 groups. Okay, 3 groups, and 3 minus 1 equals 2. So it's going to be 2. There are 3 groups, minus 1 equals 2. Within degrees of freedom is going to be all of the degrees of freedom added up for the snowboarders, the skiers, and the neither groups. Okay, so what that means is we need to remember how many people we have in each one of those groups. So this is going to be the number of degrees of freedom in the snowboard group. Okay, there's 9 people in the snowboard group, so degrees of freedom for that group is 9 minus 1, that's 8. Plus the degrees of freedom for the skier group, there are 7 people in the skier group, minus 1 is 6. Plus the neither group, there are 8 people in the neither group, 8 minus 1 is 7, 21. Therefore, the mean square for the group, okay, is the between sum of squares divided by the between degrees of freedom. Okay? 1.818. The mean squares for within is going to be the within group sum of squares divided by the within degrees of freedom. 0.20677. Got it? That's how we calculate the mean squares. Back to the slides. Now that we have the mean squares, we can calculate the statistic. Now, for analysis of variance, the statistic we use is F. If you remember, we've seen an F statistic before when we talked about the multiple regression. All we're doing to get the F is we divide mean squares of the group divided by mean squares within. So the mean squares is an estimate of the variance. This is why it's called analysis of variance, because we're dividing the variance between the groups divided by the variance within the groups. That's what's happening. So F is going to be the mean square group divided by the mean square within. So when we do that, we're going to get F when we divide this divided by this. 8.79. Okay. Now, in real life, we seldom do all those calculations. Instead, we let statistical programs do the calculation for us. So in Excel, the way we do that is we go to our data analysis tab. And just so you know, when you do this, we call this an ANOVA for a single factor. A factor is an independent variable. We only have one independent variable here. It has 3 levels. One independent variable with 3 levels. One independent variable, 3 levels. The independent variable is the sport that you like, and the levels are snowboard, ski, or neither. So what we do is we select the range of where those are. Now for this to work on Excel, they have to be right next to each other. And when you do that, you click OK. This is what you get. So let's check our math. Let's see if we are correct. If you remember, we calculated our between group sum of squares as 3.636, and the between group sum of squares right there, 3.636. Good. We calculate our within group sum of squares as 4.342, and there it is, 4.342. Our degrees of freedom are 2 and 21. Therefore, when we divide this by this, we get this. The mean squares for between groups is 1.81. The mean squares for the within groups is 0.206. Let's just check those, make sure they're exactly the same as when we calculated them. Oh, look, there they are, beautiful. And the F statistic we calculated was an 8.79, and the one that Excel calculated was an 8.79. Now, lucky for us, they also gave us the p-value, right? So we don't have to mess with it. They also gave us the F critical, which is right there. But you do, in the back of the book, you have the table to look up these if you would like to. When you look these up for analysis of variance, you need both of the degrees of freedom in order to do that, okay? And remember that sometimes the within is called error, just so you remember. All right. Now, here's what we are gonna do. We are going to show you how to do this using RStudio, because in reality, what we're probably gonna do is do this in RStudio more often than not. So this is RStudio. I already tested it out, but here are the data that I've already imported. Same stuff, right? Same stuff that we saw before, all 24 people and their time on the mountain, okay? Now, to run an analysis of variance, you have to create what's called a model. Now, you can name each model whatever you want. You can't reuse the name, but literally you can call it anything you want. So some people, they often say model one, etc. I don't care what you call it. RStudio doesn't care what you call it. I'm going to call my model, I'm going to call it Lupe. My model's name is Lupe. And what you need to do is you need to tell RStudio what Lupe should be. Okay, there's a couple ways you do this. You can create a little arrow to do it. It says Lupe is going to be this, right? That's what you're going to do. So that's one way. There's other ways to do this actually, but arrows are fun. So Lupe is going to be an analysis of variance. In RStudio, we call it AOV. And then you take the dependent variable first, which is time on the mountain, and then you put a tilde, meaning I want to separate time on the mountain by the sport that you prefer. And that's it. That's going to be a one-way analysis of variance. So let's just, oh no, look what happened. Nothing happened. It did happen. Something happened. You just can't see it. All we did is created Lupe, right? That's all that we did. So for RStudio, that just knows that we created Lupe. So we need to say, all right, well, I want to see what Lupe is about. I want to see what my statistic is. So what you have to do is write summary, and then parentheses, write Lupe's name, write the name of your model. And when you do that, here's what you get. It's the same information that you saw before. Here's the degrees of freedom. Here's the residuals degrees of freedom. Residual in this case would be the within, right? So between sports, within sports, right? Sum of squares. Here's our mean square that we calculated. There is our F, and that's the p-value right there. So there's one thing you should know. Whenever you calculate this, all this is saying is that there's a significant difference between at least one of the three groups and at least one of the other three groups. You don't see the means here. You have to tell it to give you the means. And so in order to do that, let's go ahead and try it. We're going to do t-apply. This is going to say, I want you to separate stuff for me. And in this case, I want you to separate time on the mountain by, in this case it's a comma instead of a tilde, I don't know why, by the sport. And then the statistic I want you to give me is the mean. And when you do that, this is the average time on the mountain for the neither group, the skiing group, and the snowboard group. That significant F value right here, all it says is there's a difference between at least one of these and one of the others. It could be more, could be less, we don't know. It just says there's a difference there somewhere. That's why the second half of the chapter is about figuring out what we're supposed to do. Before we do that though, let's go ahead and give you some data and have you try it for yourself. So go ahead and calculate with these data right here. All right. In this case, I have 24 people again. And I want to know, do people who wear glasses watch significantly more screen time than people who wear contacts or people who wear neither contacts nor glasses? Notice one independent variable, which is categorical, but it's got 3 categories. One dependent variable, which is continuous. So I want you to take these data and calculate each of the different statistics that we need to for the analysis of variance. Okay, so let's go ahead and do this. We'll do this easy ways and hard ways. Let's go backwards this time. Let's do it in RStudio first because that's the easiest way to do it. So for this one, I need to attach actually I'm going to detach what I had before just to make sure that the variables are not going to mess each other up. So I'm going to get rid of the set that I was using before, which is the one-way example for fall, right? This one. Okay, now I'm going to attach the one I want, which is called, I can't remember what it's called, ANOVA example class. Okay. ANOVA example class. Okay, now that I've done that, if you remember, I wanted, let's find that right here because otherwise, ANOVA example class. Okay, here are the data that we wanted. Got all the data we want. Now remember, I think there's a significant difference between people who wear glasses and the other kinds of eyewear on how much screen time they use. Okay, so I think there's different amounts of screen time depending on the eyewear. That means the dependent variable is the screen time. The independent variable is the eyewear. So let's create a new group. This one is going to be called Molly. I'm going to call my model Molly because I can call it whatever I want. It doesn't matter. I make a little arrow. I say AOV, and then in parentheses, I put the dependent variable, which is screen time, and then a tilde, and eyewear. And when I do that, oh, nothing happens except it did happen. It created a Molly model. And now I'm going to say summary of Molly. When I do that, here is all the information that I need. Here's the sum of squares between. Here's the sum of squares within. This is the mean square between, mean square within, degrees of freedom between degrees of freedom within. Here is the F value and the P value right there. Just to remind you, if you want to look at the means, then you can't just write mean. It doesn't work that way because you got to split it, right? So I need the mean of screen time, comma, which is divided by eyewear, comma, and I want the mean. When I do that, it gives me the mean amount for each one. Now this is telling me that there is a significant difference, because this is p-value is less than 0.05, between at least one of these means and one of the others, and I don't know which ones. All right, I know it's probably glasses and none because it's the highest and lowest, but I still don't know if glasses and contacts are significantly different or contacts and none are significantly different. Now, if you want to do this on Excel, then we can go through the steps of how to do this. So let's go ahead and create a few things. Number one, let's get the grand mean down here. So let's get the grand mean, which is going to be average of everybody, except that I am in, no, I'm in the right place. Okay, average of all the screen time. Okay. And then I also want the sum of squares, which is the total. Sum of squares total is going to be the deviation squared of all of these, right? Now, when I split these, I'm going to just freeze that top row so you can see what I'm looking at each time. When I split these now, let's make a glasses group, a contacts group, and a none group, meaning they don't wear contacts or glasses. The screen time for the people who wear glasses is right here. The screen time for people who wear contacts is right here. And the screen time for people who wear none is right here. Okay, so what you do is you take, let's get the mean of each of these. And it's going to be the average of those, 8, and then let's do that for each of those. Let's get the sum of squares for each of those. The DSQ for each of those is this. And let's get each one of these. All right. Then we need to get the deviation for each of the groups, which is going to be this minus the grand mean, which is right down here. Okay. I'm just going to keep that where it is so I can just go like this and like that. All right. Then we square those. And we do deviation squared. All right. Then we take each of those times n. Now, in this case, n is equal, so we could add them up and times them afterwards, or we can times them individually. It really doesn't matter, but it's going to be each of these times n. In the book, they tell you to add them up and then times it by n. It doesn't really matter which order you do it in. Equals this times, in this case, we have 8 people in each group. So when I add these up, here's what I get. And so the sum of squares between is the sum of each of these. Okay? The sum of squares within is going to be the sum of each of the sum of squares up here. When you add those together, you should get the sum of squares total. It's the same. Good for us. We got it. Now we need the degrees of freedom to try and find the degrees of freedom between are going to be the number of groups minus 1. There are 3 groups. Minus 1 is 2. Degrees of freedom within is going to be each of the group's degrees of freedom added up. And so there's 8 people in the glasses group, minus 1 is 7. So their degrees of freedom is 7. Plus 7, degrees of freedom 7 for the contacts group, degrees of freedom 7 for the none group. And so 7 plus 7 plus 7 is 21. All right. Then the mean square between is going to be the sum of squares between divided by the degrees of freedom between. The mean square within is going to be the sum of squares within divided by the degrees of freedom within. And then we get F as the mean square between divided by the mean square within. 3.792. Let's see if that's the same as what we got over here. Is it the same? 3.79, and then they rounded that last one to 3. So that is correct. Now, if you wanted to do it just on Excel, here's how you would do it. You'd go to data and then data analysis. ANOVA, single factor, factor means independent variable in this case. You select the area that you want to use, and so I'm going to select, I don't select the means, just the raw scores. I have labels, and when I do this, there it is, 3.792922. That is exactly what we got before. All right, thanks everybody.